I took early retirement, so I'm just coming out 58 now. I was planning originally at 60. So I took the early retirement in order to kind of give back, and I was financially free to do so. When you suggested mentoring, that fitted my plan to get involved in teaching. I mean, I am enthusiastic about this kind of thing. One of the things I would like to communicate at something like that is how little time that it's taken me to be able to give something that was really useful to the candidate. I think now I've been working with Angelo, I know he can get a career probably anywhere he fancies in the world and do very well at getting a good position, wherever that is, which he might not otherwise have had. And that's the difference for me. The mentoring, from my perspective, would be want to be with somebody that is that self-motivated. Yeah, it was a pretty rewarding exercise, actually. So, because I've not taught anyone quite like that before. I've mentored young graduate engineers in maybe 1 or 2 years experience as an oversight, but not quite like that. And it went better than I thought it would. I've tried to explain some of this stuff that we covered to experienced engineers, and I've not got as far as I have with him. So he is an exceptional candidate, but that's good in some ways, because the point is to try and prepare an engineer, a future engineer. Initially, I just was generally talking about chip design, the things that you don't get taught at college, about self-checking regression tests, reviews, and revision control, and what the difference between front and back end, and what the flow. I said, well, let's do a review for me. So I will look at it and I will recommend changes in a category of nice to have and recommended and must fix. I've learned a lot about how I could do this better, but I think it went better than I thought it could possibly do.
So you made an interview with him before you decided to mentor him, because we said, okay, is it worth your time?
Yeah.
So what did you see in that interview before you started the mentoring?
So the main thing I tried to do at the interview was as if you were a graduate engineer. So he'd done this project. So we talked about that. So it was that. And that's kind of what I was looking for, that initiative. So I knew, given that at that time we had agreed to do only half an hour each fortnight, that I needed somebody that could pick up stuff quickly and then in the interim run with it. And I found that in the interview. And I wouldn't go into this again without going into an interview process, I think. You wouldn't just say, I wouldn't take it on spec from an academic record or whatever, or even a list of things somebody's done in a project without then talking to them about, like you do an interview, normal interview. Somebody says, like, they claim to have designed this. So you talk to them about it, and it becomes quickly obvious that they really did do that and had some innovative stuff, or in fact, they had a lot of help and were just one member of a team and they weren't necessarily the lead. And so I was looking for those kind of things. And I think that's how it worked out, because we've seen, like, we're taking on implementing a FSM-based RISC-V processor and getting it to a regression test and getting it to pass the RISC-V international tests, relevant tests, was a lot of initiative. So I think if I was interviewing again, that's the sort of thing I'd be looking for again. So I think that, and you instigated that, but I think that was really worthwhile. No, I mean, that's true. If a future candidate from wherever, actually, I would have, yes, I mean, he's right. We'd want to have at least demonstrated that off their own back, they've at least taught themselves enough from books. This is what Angelo did, taught himself enough Verilog and then tried to put a project together, which was at a state that at least demonstrated they can get something working on an FPGA. I agree that the sort of tutorial sessions and mentoring sessions that I did with Angelo were formed by the fact that there was a lot of foundation. If we'd started from somebody who hadn't been at that point and already knew enough about Verilog and FPGAs and generally logic design off their own back without necessarily forming it, then would have spent half of that time simply trying to teach them about logic, binary, Boolean, and that is really what a university should be doing. A lot of the stuff you already have in chip school, the overview of process systems, SoC systems, the overview, having access to how to use synthesizers and layout tools, that is the thing. And I think the real benefit of chip school as a complement to their academic studies is that you can put them to use straight away.